First, let's see that this works. Okay. Yeah, so this is 20. So let's talk about what just happened.
That was some voodoo that just happened right there.
Yeah. Hi friends, my name's Logan. I've been teaching myself Haskell, and I have a treat for you today. My friend and former coworker Kaleb joined me on stream to learn a little bit of Haskell. My hope is that if you're a beginner, if you're a programmer that's never touched Haskell before, this would be something that could help get you started. We walk through how to install it and the basic syntax and solve a few basic problems. It was a bit of a blind leading the blind situation, so I did my best. I think I should have talked more about data types, and if you have any thoughts about what I should have covered or what I should maybe tell Kaleb next time if he's willing to join me on stream again, please drop them in the comments below. And if this video is helpful, if you like these videos, be sure to hit the thumbs up and subscribe to follow for more videos. And yeah, let's get into it. Thanks for watching. Yeah, let's go ahead and get started. So do you have brew installed? Homebrew?
Yes.
Okay. So let's just do like a brew search Haskell and see what's out there. I think it's called Haskell-stack is what we're going to end up using, but I just wanted to make sure.
Sure, yeah.
There's a couple different, okay, so there's just that one. So let's go ahead and brew install Haskell stack. There's a few different like options. You can just do like I think you can install ghci, which is Glasgow Haskell compiler. It's like the de facto compiler for Haskell. I think you can install that straight from brew, or you can download like the binary for it. There's also a packaging system called Cabal, but Haskell stack I think is going to be the closest thing to like getting started with Rails, you know. So let's go ahead and do you have a browser window handy? I'm curious to just let's just do a quick Haskell stack Google. I'm wondering if we need to like put anything, like export anything to your path. Or you could run like a which stack to see if that works.
Yeah. Okay, so back up just a second. Sorry. What am I searching for?
Okay, just so search Haskell stack.
Haskell stack.
So just scroll down. So we used brew. Okay, it doesn't look like we need to do any like exports to your path or whatever. Like we should just be good to go. So why don't we go back to your terminal and then like hop into a directory that you don't mind, like just like a scratch pad.
Sure. Haskell. Logan.
Cool.
Right.
And then let's just do which stack and see if that's executable. Stack. Okay, cool. So then if we do, let's just run stack and look at the help commands.
Okay. Tell me if it gets unreadable, but I'm going to.
Okay. Yeah. No, I think the text is good just for the sake of like the Twitch viewers out there.
Right.
So what I'm looking for is the new command. And so just let me just lay out my plan here. So my thought is just let's get a basic like Haskell project, like hello world type thing running, and then maybe we'll hop over to like like CodeWars or something, and then we can use their GUI and stuff to do the problems if we want, but then we can also kind of do it in our own editor and stuff.
Right.
So it says create a new project with stack new. So I think we just do stack new and then give it some name. So just want to do
stack new.
Yeah, sure. Let's see if that works. And this is totally going to be blind leading the blind here. I'll probably probably do a lot of embarrassing mistakes. I'm hoping that chat will help me out.
Right.
If I'm missing obvious things. Also, I'm like routinely having to turn my mic gain keeps deciding that it wants to jump up. So, okay, how we doing? Did it?
All right. Yeah, it looks like we've got success here.
Okay. Did it like create a new directory in here? Or did it just create? Yeah. Okay, so we probably have to
change into that.
Yeah. And then I would just pop that open in whatever editor.
Okay. I guess I'll just do this. We'll see if Vim can handle Haskell out of the box, because I definitely haven't installed any packages.
Oh yeah, I don't know how much help I'm going to be there, but
we'll figure it out. I'm sure it'll be good enough.
Cool. So
here we go.
Like, what kind of package management system do you have for? Is this NeoVim?
This is MacVim.
Okay.
The package manager that I use is Vim Plug, I think is what it's called.
Okay. Is there like a search system? Because that's probably going to be really helpful.
Sure. I mean, we can. What I typically just search it. So yeah. Vim Haskell.
We'll probably want. I mean, we'll definitely want like syntax and stuff. How about try this? Try Vim Haskell language server.
Okay. I do have ALE installed, which does some
ALE
checks. Vim ALE.
Oh, okay.
So it's like a linter / all kinds of code checks.
Okay. Let's see if configure your editor is one of in the outline there. I wonder if Vim's on there. Vim or NeoVim. The very bottom, yeah.
Yep.
There you go. Can use COC, language client, NeoVim. Is that familiar? I'm not a Vim user.
I've seen this, but I have not set it up. This is getting too fancy for me. Let's just see. Let's see what it does. Like, it highlights it.
Yeah, it highlights
it has
stuff,
some built-in highlighting.
That might be.
I don't know what else you're looking for.
We could probably just roll with that and then see how we do. Like, I wonder if we probably won't get any like linting or anything, but
right. Just do a quick check for Haskell. No.
Not seeing anything.
Supported languages and tools. Oh, I just have to search the full list.
Oh, there you go.
So, hey, it's a bonus thing if you're looking to learn.
We're looking for go back. We're looking for I think I saw HLS.
Oh, okay. Oh, there's a bunch of stuff. Yeah.
HLS. Yeah, Haskell language.
Familiar. Okay.
Yeah.
So, okay, this is the Haskell language server. Does it come with Haskell when you install Haskell Stack? Is this what we were looking at earlier?
I don't believe so. I think it is. So, can you install HLS with Ale? Let's try that.
Yeah. Search HLS. Is that what it would be called? Do you think it's a brew package? Like, I'm just kind of flying blind here.
Oh, I thought Ale was like your I thought you had some kind of package manager for Vim.
Right. But so it supports this out of the box, but I don't know how to install this.
Oh,
so
okay.
The way Ale works is it integrates with various tools that you have installed, and it auto detects them.
Oh, so okay. So maybe
I would have
that's
to
already
install
working.
Haskell language server somehow. Yeah, possibly.
Okay.
I bet there's a way we could figure this out. What's some invalid syntax I could?
You could just like delete everything after the equal sign. You could delete default main.
Okay.
Save. Let's see. If we get any kind of.
Oops, I just hijacked the screen. I'm looking at, so it's using Cabal GHC for available linters. Enabled. It's got Cabal GHC
it's got HIE, which is I think the old version of Haskell language server.
So, I don't know.
I
feel like
try. Yeah, I think we'll be fine. Let's just roll with what we got. We got syntax highlighting. That's pretty decent. So can we bump up the font a little bit more?
Sure.
Cool. Like as large as your like can stand, I think.
Yeah. Here, so the problem that I'm battling right here is screen puts a little subtle border around, but it cuts. Since my editor doesn't have much margin, it like cuts into the view a little bit. So I'm trying to get it centered instead of. How's this look? I could go a little bigger.
That looks great to me. Okay, so Nathaniel says, download the HLS binary from GitHub releases or compile manually and come back in a few hours. So, nice. Yeah, maybe we'll just roll with what we got. Thanks for now.
Well, it sounds like we could download the binary, right? If they have it compiled for Mac. I don't know. I don't know what value it brings, so sounds good. Let's learn some Haskell.
Yeah, that sounds good to me. Okay, so then so can we go back to your file tree? Mm-hmm. I'll just kind of show you like Tot BWF says GHC up also works really well. Yeah, GHC up is another like way of installing Haskell, but I wonder if GHC up has like the same. Oh, you know what? GHC up also could install like Haskell language server for you. I don't know. Let's just roll with what we got, and if we run into problems, then we can explore that. So if you do stack, welcome to the stream, by the way, Tot BWF. Thanks for joining. Yeah, if you do stack GHCI, then preparing to install. Yeah, it's probably gonna do what I mean. This is really, and I apologize to the stream. This is really blind leading the blind. So I mean, it's kind of silly that I'm like teaching you this, but maybe the stream. This is two beginners like trying to get started with Haskell. Well, that's more how we should frame this, I suppose.
Right.
So I'll show you everything I know, which is not much. So the way I understand this to be working is, it's basically doing what is the equivalent of like a bundle install, for you, since you're it's like you're booting up a console for like a Rails console, and it's automatically going to go fetch all the dependencies for you before it needs to even run the console. And all of that will be defined in your package.yaml. So while that's going, we could pop open package.yaml. Yeah, so this is just like a YAML file that it's kind of like a package.json, I suppose. So if we keep going down, we'll probably see some library. So right now the library has like source dirs, and dependencies looks like it's just got base.
What is base, like the standard library?
Yeah, I believe so. And then tests, probably there's nothing, just the tests directory. Yeah, main spec.hs. So and chat, feel free to throw in any pointers or suggestions. So if we hop back to the file tree,
like browse around. I've got the it's not gonna show up there.
Oh, that's okay. So basically, this app should just have like the app directory should just have like a main I think it's just like a main.hs that just it's kind of like that exports the this is like main sum func. So this is typically just stays like this, and then everything you do, my understanding is everything you do is in the source directory. So this is kind of like just you're exposing your app's like executable main function outside of it. So you basically, I mean, wouldn't really touch this except to change that sum func to something from lib. So if you hop back and look at the source dir, we should just see a I know we haven't gotten into actual Haskell syntax yet, but while we're waiting for this stuff to install. So so we should have this lib, and actually can we go back and just see what's in? Is lib the only thing in the source directory?
Yes.
Okay. Is there a, if we go back one level, oh, there's a test. Okay. And then test, does test have that spec.hs? Okay, so I thought that lib and spec were in this, like lib and test were both in the source directory, but I guess not. So yeah, basically everything you're gonna do, like, I mean, you put your tests in the tester. It's kind of like your spec or tester in Rails, and then source is like closer to your app directory in Rails, like where you put all your actual code.
What's this setup?
Yeah, let's look at that. Import.
So that's what we were looking at first.
Yeah, I guess that it's a good question. I don't actually know, so
okay.
Anything I said would just be speculation. I think sure. maybe this is like how your app gets compiled, like how you point your builder to like how to start up your app. Tot says it's if you want some stuff done during the build process. Okay, that's helpful. So I guess maybe stuff that you'd want to have happen at build time, but not at runtime.
Interesting.
Nathaniel says the low-level Cabal interface is implemented using setup.hs scripts. Okay, so Cabal is like your package manager. It's kind of like bundler.
Okay. So we have like this Kaleb.cabal, which I guess is the package. So for my Ruby brain, that's seeming analogous to like a gem spec.
Yeah, I believe so.
Okay, and this is the dependencies, or package.yaml.
I believe so, and I think that like if you go the stack route, I think you just I don't want to mislead you. I haven't really done a deep dive into like actually setting up this stuff before.
Sure. Like a whole project with a bunch of dependencies and stuff.
As Taras says, stack uses package.yaml and generates the Cabal, right? So unfortunately, people on stream aren't going to be able to see the chat because it's like white text, but that's all right. Unless you could like easily switch to a dark mode, but it's not a big deal. So is the installation done?
What am I looking at? It looks like I'm at a prompt.
Yeah, so remember we did stack ghci and it started installing your dependencies, and then it looks like we're in a console right now. So we should be in ghci. So if you look like kind of a little bit more than halfway down your screen, you should see ghci version 8.10.4. And then it says, it's compiling lib, compiling main, etc. So you can clear this if you like, and then you could just throw like a 1+1, and that should work. Cool. Yeah. So you're running Haskell. Yay.
Yay.
And I think try just running main. Okay, some func. Right. So I think what main does is just it prints out some func. We could check that.
Maybe. Where was main? Source.
Yeah, there it is.
Yes.
Well, yeah.
Yes,
so
okay.
so yeah, the app/main.hs calls this function, and this does put string line some func. So yeah, that's basically your hello world. So we have a project up and running, but why don't we just go over some like Haskell basics in the REPL, so that
Okay.
Let's see what this is going to be a learning experience for me too. So the way you define functions, actually, are you comfortable with me like switching to cursor mode in screen and like typing some stuff?
Sure. Yeah, go ahead. Have at it.
I really want to let you drive most of the time because I think that's the best way to learn is to do the typing. Functions in Haskell, I think the biggest like hurdle to jump is like the lack of parentheses. But I guess from Ruby, Ruby parentheses are optional for the the rightmost function call. So you might be more comfortable with it than most. So we can define functions just simply with the equal sign. So this is a very simple function. So what I've just said here is there's a function called add, and it takes two parameters, x and y. And the equal sign in Haskell is denotes like substitutional equality. And I think there's some caveats with like left hand and right hand side. But basically, what we've just said is that this expression is equal to this expression. So anywhere the compiler sees add xy, or rather add some integer and some integer, or some number and some number, it can replace. So let's say it sees add 1, 2. This expression is equal to 1 plus the expression 1 plus 2. Does that make sense? So
yeah, so it's kind of more like a mathematical or algebraic equality.
Yeah.
Than an assignment that you would think of from other languages.
Yeah, exactly. It's not an assignment. Not really. I mean, I guess you can kind of think of it that way, but it probably won't help you, and it'll probably hinder you to some extent. You can say like x equals 1, and then if I type in x, it is 1. And I think the REPL will even allow you to reassign x. Yeah, it will. But only because it's a REPL, the context of a REPL. Like this would be a compiler error to assign it to 1 and then assign it to 2.
Gotcha.
So I believe it would. So that's let's see what's the other what are some other good things to get you started with? So the other biggest hurdle I think would probably be function application. So I'm going to introduce you to some ghci, some like interactive ghci like commands. So first of all, if we type in, well, I'll let you drive for a second. So if you type in colon ? That pulls up the help menu. Yeah, okay. Nathaniel's bringing up Nathaniel brought up a good point. So we said x equals 1. You could think of x as a function that takes no arguments and returns 1.
Okay.
So rather than saying x is a variable that is equal to 1, it's more like x is a function that returns the value, like a constant function, you know?
Right. Right.
Okay, so
That keeps the paradigm consistent. So you're not thinking of
yeah,
the equal sign as like switching jobs.
yeah. And I'm gonna explain the like the type and info like ghc commands to Caleb. But if you have any ideas of like what are good things to introduce to a beginner, or to two beginners, then like please shout it out and we'll explore that. So what I was going to show you is you can see helpful commands in here. The really the two most important ones are type, so :type and :info. So if you do :type and then space add, it will tell you what the type of add is. So why don't we go ahead and do that for x as well? So type add. Type x. Yeah.
Okay.
Okay.
Yeah. Okay. So it's a function. Wait.
Yeah. So let me explain this. This is a little misleading. So,
Okay.
This fat arrow, for now we can kind of like somewhat ignore that part. It's basically a type constraint. So it's saying where a is some number, and the reason it's saying that is because there are multiple number types. There's integer and integral and floats and that kind of stuff. So add is a function. This is the type signature. This whole thing is the type signature of the add function. Well, maybe we'll start with x. X is a p, where p is some num, right?
Okay.
And this double colon is you can read it as has the type of. So x has the type of, and then the way I usually read this is when I see a fat arrow is x has the type of p, where p is some number. So I'm going to make this a little bit more explicit and say, as I type this in, I can tell the compiler what I want 1 to be. So I'm going to say x is equal to the value 1, where 1 has the type of integer. So I'll do that, and then I'm going to type in type x. And then now this is a simpler signature, right? So this is just as x is of type int. So
interesting.
Or, as Nathaniel pointed out, we could think of this as x is a function that has the return type of integer. So it returns an integer value. So with add, actually, let's do this now. Let's well, no, I'm
Can I
yeah.
try something?
Yeah,
I'm curious
please.
about this type of plus.
Sure.
I assume add inferred. Oh, I can't do that.
Yeah, so you'll have to wrap parens around it because it's an infix operator.
Wrap
so like
parens,
a left.
like
so do
this?
like a yeah, exactly.
Okay. Cool.
Yeah, so plus is actually a function. And we didn't go over add yet, but plus is a function that you can read this right side as it takes, let me switch to marker mode. It takes an A and then another A and then returns an A.
Okay.
So you can kind of read this as it takes two A's and returns an A. So that makes sense, right?
Okay.
You take two numbers and return a number. But where this gets kind of mind-blowing is Todd is pointing out that T is short for type. Thank you, Todd.
Oh, nice.
Appreciate that. So you can also read this like, so we might read a function like in JavaScript. We might say, this is gonna, I'll erase this in a sec, but we might say something like this, right? I guess I should have used the fancy like arrow syntax, but x plus y, right?
Sure.
Spacing's wonky because of lag, but it takes two integers and it returns x plus y. But so we could think of the type as like takes two a's and returns an a. But it's also perfectly valid to think of it as it takes one a and it returns a function from a to a. So it's like, because parens are kind of right associative, you could, num is a thing that basically takes two arguments, and those can be applied separately or at different times. So for instance, +1 is a valid expression, and it doesn't know how to print it. So it's saying no instance for show arising for use of print, because the REPL prints it evaluates and then prints everything. So it's saying I don't know how to print a function. So I'm going to assign it to add 1, and I'm say add 1 is equal to +1. And then I can say type of add 1. So you'll notice like one of the a's is gone now. So what do you figure will happen if we pass a number to add 1?
It will increment it.
Yeah, exactly. So we've basically
Okay.
just done partial application here. And actually, can we hop over to your REPL? Oh man, I'm not
to the editor.
Yeah, to the editor.
Sure.
Sorry, not REPL.
It's all right.
Oh no, I'm not good at Vim, but I was gonna basically try to type.
So press A.
Okay, insert mode. Okay.
Yeah.
So I was just gonna kind of show you maybe a little bit more intuitive way of thinking about this. So
okay.
Function add, we could say function add returns a function, right?
Mm-hmm.
And then I could say that function returns x plus y. Whoops. I don't know.
Doesn't know how to format JavaScript in Haskell.
Yeah. I realize I'm doing something kind of weird here, but I don't know if this is helpful, but you could write it this way in JavaScript, right? And then you would just have to say like add 1, and then you'd have to invoke it again because this returns a function, not an integer.
Right.
So invoking add will return this function, which takes a y. But as soon as you run add and pass it a value, this x value is now locked in. It's like closure. So, if we assign add 1, like const add 1 equals add 1, then we could carry this function around all day and then apply it to different values, use it multiple times, and it just increments some value, right? So that's kind of what's going on. And Nathaniel's pointing out that would have been a much better way of writing it. The new like ES6 syntax makes this really nice, actually, because you could just write it like so. And that would be the same as this up here. So add is a function which takes an A that returns a function which takes a B and then adds A to B. So I don't know if that was helpful or not. So yeah, we can hop back to the REPL.
So I guess it's kind of adding a constraint that functions should, like, the illusion of calling a function with multiple arguments is really more of a syntax sugar in a language that's constrained to just having one argument per function.
Yes, that's a good way of putting it. So another way to express that is to say that so this process of turning a function which takes two arguments into many functions which each take one argument, that is called currying. Have you heard that term before?
Yeah.
To curry?
Yeah.
Yeah.
Curry,
So
yeah.
the guy who like invented currying or discovered currying is named Haskell Curry. So the process that is called, the process of doing that is called currying, and the language is named after the same guy, Haskell Curry.
Nice. Okay.
But I've also heard that there was a mathematician named like Sean Finkel, like Henrik Sean Finkel or something like that. And so perhaps we should call it Sean Finkeling. But I think Haskell Curry. Oh yeah, good idea. Like you're gonna throw it in like a JS. Yeah.
Yeah. Except now I'm getting like, oh, well, why did you format it that way? Anyway, not worth it. Nice. Okay. Yeah, that's really helpful. That's really clarifying for the more JavaScript oriented brain.
Right. And you're taking this on chin. Like you seem to be like, maybe I'll throw a little bit more complexity at you because you seem to be doing fine. So you seem like you'd be well familiar with like map and filter and reduce. Yeah. Like Ruby and JavaScript have those functions. So throw a typed, like a :t map in there.
Yeah. So
this signature is a little bit different. So what this is saying is map is a function, and you'll notice there are parens here. So that means this first argument is a function from A to B. So map takes a function, and then it from A to B, and then it takes a list of A's, and it returns a list of B's. So that's pretty intuitive, right? You give me a function that turns an A into a B and a bunch of A's, and I will give you back a bunch of B's, right? That's the way I think.
Yes.
So
I wouldn't say, I wouldn't use the word intuitive yet, but I think it makes sense.
Yeah. I think what's weird about it perhaps is that in JavaScript and Ruby, this would be like object notation, right? So you would have some list,
yeah,
and then you would put a dot after this list and say dot map there and pass it the function. So why don't we try that? So and one thing I should point out is this says A to B, but it's basically just saying you have that option. You can change the type of this if you want. Like for instance, this could be a function from an integer to a string, right? Or an integer to an array even, or whatever type. But that doesn't mean we have to. We can return an integer. So it can be A to A. So we have an A to A here. We don't have a list, but you can imagine, lists are just the same as you would, constructing a list is just like that.
Got it.
So let's call like map add one on like a literal list.
All right, sounds good. So map. And you don't need commas in between the parameters, right?
Correct. So we do map add one.
1, 2, 3.
Correct.
Cool.
There you go. So pretty succinct there. I love how expressive that is. So, and you'll notice that this add one originally was this like add function up there somewhere. We partially applied, well, I guess we just used the plus, right? We defined it here. But plus takes two arguments, really. So this expression returned a function. We took that partial function and we passed that partially applied function to another function. This map is called a higher order function. That's like a functional programming term. Like a higher order function is a function that takes another function as input or returns a function as output or both, right? And feel free to
Okay, yeah.
stop me if anything is just like, yeah, I know that or whatever.
No,
so
this is good.
Yeah, so I just wanted to show you this this kind of expression. Another perhaps even more advanced than this would be like a fold, which in Ruby would be like reduce or inject. So check out the type of reduce, or sorry, fold.
Reduce,
It would be called
fold.
fold-r.
Fold-r, okay.
I believe. And chat can tell me, should I be using a different fold here? Not sure. So fold-r stands for fold right. So it just means that like denotationally or semantically, you're going to be moving from the end of the list to the left.
Okay.
And we can talk a little bit about that if we want. But yeah, so can we hop back to the JavaScript actually? The JavaScript file. So let's see, insert mode. So if I said const foo equals this, I could say like foo.reduce, and then I think the way that JavaScript works is you pass some function. So we need some function here. And then you pass like the initial value.
Yes, yeah.
Right. And this bar, I believe a reducer function is like this, that it takes the accumulator as its first argument. And then it returns, let's just say ac plus x. So then actually, could we like copy that into a node REPL or something?
Sure.
And run it?
Yes. We can. There are errors all over this. Is this syntactically valid though? We'll just do it in a REPL.
Yeah.
Node. Okay. So what do we need? We need
just
bar and this.
Yeah. Let's see if that might not work, but we'll see. Okay, cool. Yeah, it worked. So then, so 0 gets passed in as the ac, and then foo is, because we're reducing on foo, then like the first iteration, ac is 0 and x is 1. And it's going to do that for the first element. And then the next time ac is 1 and x is 2, right? And goes through that way.
Yep.
Nathaniel says fold L is the function to be careful about. And maybe we could talk about that later. But
interesting.
So we can hop back to the Haskell REPL.
Okay.
Oh, okay. Nathaniel's saying reduce is like fold L. But I think for this, it shouldn't matter which direction we go. So, so the difference here will be that the first argument to fold R is the reducer function. So like bar from our example.
Gotcha.
And then B will be like the X, and then TA is the no, I guess B would be like
foldable.
The AC. Sorry.
Okay. Yeah.
And then this will be the list we're operating on.
Right.
So
and that's T is, what does that mean?
Yes. So foldable T. So this fat arrow means there's a type constraint. So it's saying TA so where T is some foldable type. So it's just a little bit more generic than lists, right? So fold R will work on other like iterative or foldable structures. So It could work on sets, or it could work on tuples. It could work on anything
Gotcha.
that implements a instance, or like you could think of it as like an interface. So it could,
Yeah, for
you define
the
a new
C#
type.
people out there.
Yeah, right. You could define a new type and say like, I'm declaring that this is a foldable, and here's an implementation of the foldar function.
Right. Yeah,
So
yeah, similar. It's not the same, but it's similar to the concept of enumerable in Ruby. Just like
yeah,
there's a set of things that behave this way.
right. I think I'm pretty confident in saying that Haskell is going to be like way more strict about that and like how that's defined. But let's. I think probably this will be a lot easier if we just use it as an example. So
Sure.
So, we did basically a sum function, right? So we could do fold R and then just pass it the plus operator, because plus takes 2 arguments and returns.
Yeah.
So yeah, you could do sum equals or do it this way. That's good. So you'll have to wrap it in parens. Yep. So we're passing fold R the plus function. Then we need some b as our starting value. That's the next argument.
Okay.
So we can make it any integer, but why don't we start with 0?
Right.
And then
Makes
another
sense if we're
space.
summing a list.
Yeah, and then any like list of integers.
Okay. 1, 2, 3. I think we can calculate that in our heads, and we just did that in JavaScript. So
yeah.
Cool.
Yeah.
Very succinct.
Yeah, very, very expressive. And then why don't we go ahead and do what you started with, which is like say sum. So you could say sum equals, and then just those first 3 like tokens. So like fold R plus 0.
Oh, okay. Yeah. Fold R. Gotcha. So this will produce a function that you just pass a list to.
Exactly. Yeah. So now we could just say sum 1, 2, 3, 4, or sum 1, 2, 3.
12. Okay.
Yeah. So you can imagine how quickly you can build, these powerful abstractions, like by partially applying functions, or like function like factory functions. And so Astaroth is saying we should talk about ranges, or introducing the range syntax. So just like in Ruby, you can do like 1.3 or 1.10. Or actually, I think it has to be. I'm gonna drive for a second. Does it have to be 2? I wonder if it's because like in Ruby, it's like 3 is exclusive, right? Okay, yeah. So that's not a thing. You would just have to do .9. But I think maybe the next thing we'll jump into. So I think I'll explain laziness, and then why don't we jump into like code kata or CodeWars or something, and like try a couple easy problems. Sound good?
Sounds great.
Okay.
Yeah.
So we can do ranges like this. I could say, do you mind if I type? So
go ahead.
So I can do this, which seems a little weird, right? So this is a list starting at 1. And if we type my list right now, then you'll just see like an infinite list start printing to your screen. But there's this handy function called take. You give it an integer and a list of A's, and it gives you a list of A's. So you say how many of some list you want, and then you give it a list. So like maybe I'll start with head. So head, just you give it a list and it gives you one of that thing. So obviously it gives you the first element. So I can say my list, head of my list is 1, right? Or it could say take 5 or 6 from my list, and you get 1, 2, 3, 6. So this is just demonstrating that Haskell is lazily evaluated by default. So I think there's some like exceptions, but so when we say this, it's saying like create an infinite list starting from 1 and store it in this value. And it says, sure, here's your infinite list. And it actually hasn't evaluated this expression yet. You know, it's just sitting in like a thunk, I think it's called, THUNK.
Thunk.
And then it's not going to actually look at like peel this open until we use it. So when we say head my list, it says, okay, you need this list. Let me generate the first element, return that. Okay, we're done. So then now it's done. It's not going to keep evaluating my list. But if you type in my list, it will say, oh, you need all of my list. So it'll start generating it out. So that leads to some very interesting implications. And that's why there's like differences between fold L and fold R. You know, if you're folding left, like if you try to fold right on an infinite list, that's kind of like you're starting from the end of the list and going left, right? So it's a little bit tricky because I'm trying not to rabbit hole myself, but there's some interesting
Right.
like ways that Haskell like implements this fold R function to actually, like, I think we could, for instance, take 5 from, and I'm going to wrap parens here. So I could say take 5 from fold R, or sum, right? We had sum my list. So we can sum the infinite list. No, wait, this isn't going to work.
Yeah, sum is going to return a number.
No, because yeah, sum returns a single value.
Mm-hmm.
But what we could do is say take 5 map add 1 to my list.
Okay.
So this is going to map this add function on an infinite list, incrementing each value. And it's going to take the first 5 values.
Yeah.
So it's smart enough to figure out, you know, not to eagerly evaluate this and like generate the entire mapped output of that. It's smart enough to realize you only want the first 5 values. And then the last thing I'll point out is you'll see this $sign a lot. And this $sign is literally just function application as an operator. So it's like saying whatever's on my left is the function and whatever's on the right is the argument to that function. So it's basically just saying, because if I didn't put parens here, it might think I was saying take 5 off of map, you know? So you have to tell it, like, evaluate this whole expression first and pass the result of that to take 5. This $sign does kind of the same thing. Yeah. And then Nathaniel's pointing out, you could say sum take 5. Yeah, so we can chain these arguments together, right? And then Nathaniel's also pointing out function composition, which we definitely have to talk about. I can't believe I didn't think of this already. This is like probably my favorite thing about Haskell. Did you ever do any Elixir?
No, not really.
Okay,
no.
That's all right. Well, I mean, you know, like from Bash that you can do like cat foo.text and then like grep something, right? And this pipe operator is just like whatever is the, you know, output of this, pass that as input to the next expression, right? So it's like you're combining these things. And I believe Bash also like runs these in separate processes or something. But we have this thing, the dot, which is a really kind of weird looking signature. It takes a function from B to C and a function from A to B, and then it takes an A and then returns a C. So it takes two functions and then some value, and then it returns some value. But if you look at these types, if we were given an A, so let's say we had, a function. So let's pass, period is this function. And by the way, we can write, I lost control of the screen somehow.
Oh.
I can't type. Wonder if I did something
Weird.
wrong. Oh, I think your cursor has to be on the same monitor as mine.
Oh, okay. Yeah, I moved it off
fine.
so it wasn't in the way.
No, that's all right. So a little bit of syntax explanation. So plus infix operators, go in between. So plus takes two arguments, one from the left, one from the right. You can write it prefix notation like this. So by wrapping it in parens, we could say, take both of your arguments from the right. Similarly, this add function is a prefix operator, and we can put backticks around it to turn it into an infix operator. So we could do these backticks and say, take one argument from your left and one from your right. And that's the same thing. So any infix, you can write it prefix with parens, and any prefix function, you can write infix with backticks. So I hope I'm not piping too much. I hope I'm not saturating you with knowledge yet. So
that's neat.
I just wanted to show that so I can point out this composition function, this dot is a function that takes two functions and then some value. So if we pass it 1, let's say 1 is A, well, we can't call foo on it, not necessarily, because foo takes a B, and this argument might not be a B, it's an A, right? But we could call bar on it, and bar would take this A and give us a B. But then we could call foo on B, right? Because foo takes a B and returns a C, and then we'd be done, right? So let's say we had, let's just pretend for a second these are all A's. So I'll just say plus 1 dot, and I'm going to write it infix this time. And then I'm going to say times 2, and then some value. So let's think through what this would do. So the first argument to this dot would be B to C. The second argument, so it would be some integer to some integer. It would increment it, right? And then the second function would multiply some, multiply some integer by 2. And then 5 is our A here. So what's going to happen is we're going to multiply 5 by 2. So we'll get 10, and then we'll add 1. And I think I need this, this $sign here. Yeah. So because it didn't know whether I was saying this or the other thing. So I had to put that $sign to say the right side of this $sign is the argument and the left is the function. So we can just combine two functions like this. And we can combine as many as we want, right? We can say, add 3, and we can say minus 2. And then maybe it doesn't like the minus 2. No, non-type. Maybe I lied. Let's see if this works. Yeah, so that works. I think maybe because minus doesn't have... That'd be interesting. It's because it's interpreting it as a negative number.
Oh, right.
So I thought I was saying negative 2 rather than minus 2. Thank you, Nathaniel. Huh, something like that.
What if you put a space in between the minus and the 2?
I think if I do a lambda expression, so we haven't talked about lambdas, but this is just like an anonymous function, kind of like a fat arrow function in ES6. It's just saying you just use this instead of, this is like saying like, I guess because it kind of looks like the lambda, the Greek letter, without missing the, little leg. So this is a function that takes an x. So this is the parameters, is to the left of this stabby arrow, and then the right side is the function body. So we get some x and we subtract 2 from it, and that works. Okay, so 5 minus 2 is 3, 3 plus 1 is 4, 8, 9. There you go. So then going way back up here, I think it was Nathaniel that was pointing out, when you see a bunch of dollar signs like this, a lot of times you can convert them into composition. So I don't think I can. Oh, I think I can actually say dot here, and then I have to add a dollar sign way over here. So first, let's see that this works. Okay, yeah. So this is 20. So let's talk about what just happened.
That was some voodoo that just happened right there.
Yeah. So this is kind of interesting, right? So remember, my list is an infinite list starting from 1. And this dollar sign is like, this is going to be the argument to some function that's to the left of this. So to the left of this is map add 1. So let's look at what is the type of map add 1. So map add 1 takes a list and returns a list. So, and it increments every element by 1, right? And then we're going to compose that function with take 5. So after we, you can read the dot as after. So if you see like f.g, you can say f after g.
Okay, yeah.
So, it's like opposite from the bash pipe, which would do the left side first and then the right side. So we're map this add 1 function over everything. Then we're going to take 5 from this resulting list, and then we're going to sum the list that comes out of take 5. So we've just kind of created this pipe here. And then, so then we could say like sum first 5 is a function. Bam. So sum first 5 is just these 3 functions, but one after another. And then we can say sum first 5 my list. There you go. And then we could pass it some other infinite list. Like, maybe I should show you that first. So let's say foo is a list. Starts at 0. Then the next element is 5. Take 5 from foo. I keep writing 6. So it's smart enough to like. It's smart enough to see the interval here and say, okay, so the first is 0, the next is 5, then the third one must be 10, and so it's just incrementing by 5 each time.
Yeah, it's clever.
So then we can say sum first 5 of foo. And that's 55. So you can build up these like incredibly powerful abstractions, and like we haven't even scratched the surface, But I think that's a pretty good intro. Chat, what else am I missing? Is there anything glaring that I should cover before we hop into? I haven't. Go ahead.
I was going to ask if there's an operator that takes composition the other direction.
There is, I believe it's ampersand. And it might be in some module. Actually, let me. So Nathaniel says we should talk about the IO monad or purity. I kind of want to just punt on the IO monad, but maybe that's probably just for my own fear of like explaining it wrong. Let me see. Haskell, compose forward operator. But you know what's cool is there is this function flip. So flip takes an A to a B to a C, and then a B and then an A. So how can I demonstrate this? So let's do sub is equal to that lambda that subtracts 1, right? So if I say sub, well, let me redefine it as xy, x minus y. So if I say sub 5, 4, that's 1. And if I do 4, 5, then that's -1, right? But I could say flip sub. So that's just gonna pass 4 as the second parameter and 5 as the first. And okay, I didn't need that $sign. So this is, if we subtracted 5 from 4, it should be -1, right? So it's subtracting 4 from 5 there. So I could make a new operator and I could call it whatever I want. Let's call it what F# and what Elixir calls it, which is this pipe with a caret. And we could say that's equal to flip dot. So now we could say like 2 plus 3 or plus 4. I always type the wrong numbers on this keyboard. And then times 2. Maybe I'm not doing that right. Oh, I think I don't need this first pipe, I think.
So 2 is a function.
Yeah, I think I'd have to say.
You have to start.
Oh yeah, I think I would have to like compose them this way and then apply the function on the end still. Yeah. So, okay. But I think there is. Whoops. No. I lost my chat window, so let me see. Astros says, yeah, just flip it. Tot says, just ignore IO for now. I think that's a good idea. Enough to explain how to sprinkle debug messages in pure code. Tot says not worth it. So Todd and Nathaniel are having a bit of a row. No, just a friendly discussion. So I do think there's like an ampersand or something where you could do this exact same kind of thing that you would do in because I looked this up one time because I really like that kind of syntax.
Yeah, there are probably scenarios where that might read a little better, but I was thinking about the dot syntax for that.
Yeah, go ahead.
If I read the dot syntax in my mind as like just the word of, it was making sense to me. And now none of the examples are on the screen anymore, so I can't read it out.
Let's go back up. So
yeah.
Sum
of like the result of take 5 of map at 1.
Yeah.
Just kind of
like of the result
after
of
makes sense too.
Yeah.
Yeah, the result of something.
Yeah. Yeah.
Anyway.
So there actually is, let me see, import data function. Then we should have this ampersand thing. So we should be able to say 1 and plus 2 and times 3. Fail. Yeah, that works. So this is 3 times 3. So and it's funny on the Stack Overflow comment. It's like people are getting really spicy. They're like, you could do it that way. It would be wrong though. Like it's like you could do that way if you wanted to write it backwards. It's just really funny.
That's funny.
I guess people have strong opinions about I guess maybe that the dot is the more mathematical way of doing it. So yeah, I think we could kind of punt on IO for now. Maybe what I could do is, could you put your cursor on the screen?
Oh, yeah. I don't even know where it is. Here we go.
Let's look at put stir line. Okay, so maybe this will be short because my knowledge is so cursory that I won't be able to get very far. But so put string line is a function which takes a string and returns this thing. So it returns a type IO of unit. So this syntax is actually a value in Haskell. So open close. So the best way I've heard it explained is like integer or int is a type. So by the way, I is info. And you can get more you can get more information about like where stuff is defined and like any so like these are all the instances of integers. So basically anything that's an int has these, you can call these functions on ints, basically is the way to think about that for now. So so if I look at the type of unit, it's unit. So what I was going to say is integer is a type that is inhabited by an infinite number of values, right? So there are infinitely many ints. Or I guess integer is maybe it's like 32 or 64-bit integer. So there maybe that's not actually true. I think there is an integer class. And this one's like unbounded or something. It's not important, but the point is this basically has infinite number of values inhabiting this type. So Boolean, right, is it Boolean or bool? Bool? Yeah, bool is just two. There's just two values that inhabit the bool type. False, true and false. Well, there's only one value that inhabits type unit. It's unit. So unit is a data type, and this is what it's called, and this is how you make one. Like bool is a data type. You can make a bool by typing false or by typing true. So if I type out true and I look, what is the type of true? It says bool. You know, if I type out false, it's going to say bool. But maybe I should say T instead of I, because that's a little bit noisy, right? But if I say, what is the type of this? It's unit. So that's a little bit weird, right? If we go back to put stir line, it says IO unit. So IO is like a type, I guess, is it called a type constructor? Let's see, Nathaniel might be correcting me here. Unit is a zero tuple, a tuple with no elements. There's only one such tuple that exists. Okay, so you can make tuples in Haskell. And you can say like first and second. It's kind of like saying head and tail of a list, and I think you can have tuples that are like many arguments. Yeah. So, anyway, so there's only one value that's a tuple of no elements, right? Oh, okay. Then Nathaniel's saying, yeah, Nathaniel's saying if you had a tuple with Boolean and Boolean, there's only four possible values, right? Because it could be true, 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 false, false, true, or false, false. So but yeah, a tuple of 0, that's, I've actually never heard it explained that way. That's helpful. That explains the parens a little bit better. A tuple of no elements. So it's basically just, it's kind of like, the way I understand it, maybe this is my new explanation, is like it's an ignorable value, or it's like an okay, it's like an ACK, right? So string to IO unit is like, it did its thing. It's like returning nil or something. It's kind of the closest thing to that. IO is actually like a type constructor. So if we look at like I was gonna say list. Say, can I look at what is the type of, is it called list? Ord. So yeah. So let's pretend this says list for a second. Maybe I should say set. I don't know. So, yeah. So, man, this is maybe not. So if we see this, it's kind of like saying, list of, Todd is saying I want K. Yeah, I guess I do want K. So, this syntax is like how you construct a list, right? And brackets, you'll see there's a star here instead of a letter. That's because we've kind of like gone up a level of abstraction. So, when I, man, this is kind of rough. Basically,
it's very abstract sounding.
Yeah. So you can't have really you can't have a generic list. And oh yeah. Okay. So Todd is saying maybe I should do maybe. That's probably a better idea. Yeah. So if I look at maybe, ignore everything below this line. So it's saying data is this keyword saying like kind of like declare a new data constructor, a new data type. Maybe A. So maybe A, there's two ways you can make a maybe A, with typing out nothing with a capital N, and then this bar is like or. So nothing or just A. And so no, like A is, because it's lowercase, it means it's variable, but it's not a value. It's actually a type. So a data constructor is like a function that doesn't take values, it takes types. So you don't have a maybe one, you have a maybe integer. Does that make sense? So if I say x is a just one, and I look at the type of x, oh man, let's say just one int. Darn it. I don't know why it's not happy with me. I think I have to do this. Yeah. So then if I look at type of x, x is a maybe int, right?
Okay, yeah.
So think of it like, so in Haskell, like lists have to be homogeneous. Like all the elements of the list have to be the same type. So you can't say one and then string. That'll blow up. So it's saying there's no instance for like list of char. Like basically list of char is not a number, right?
Right.
So a list is like a data constructor that takes some types. You have a list of integers, or a list of strings, or a list of characters, or a list of, foo bars or whatever. Where was I going with this? So maybe can be nothing. And if we look at the type of nothing, it's a maybe A, because it doesn't know what the A should be. Just like if you have an empty list, you don't really know what type should go in there. Like if you had a list of numbers and you took all the numbers out, now it's kind of like an empty list of numbers, you know?
Right.
So an empty list is a valid list of numbers, even though there's no numbers in it. Why did we get into all this? I'm trying to. Oh, maybe because the IO thing.
And yes, the IO is an empty tuple.
So IO is like a data constructor, I suppose. So there's this type IO, and see it says IOA. So you could have a function that's an IO int or an IO string, or you could have an IO unit, which is just like it just returns an empty tuple. You know, it's kind of like returning nil a little bit. So maybe that was not really worth explaining, but there you go. So maybe the last thing I should point out is IO is like when you see IO, it's telling you that it does some impure effect, right? So one of the things we haven't really said yet is that Haskell is a purely functional language. Like there is no mutation. We've kind of been breaking that because we're in a REPL and we can like reassign things.
Sure, yeah.
But there's really no
the same as mutation.
Yeah, and there's no like pop or shift on the on lists. I mean, anytime you do that kind of thing, you're really just creating a new list. And like if I say head 1 2 3, like I mean if I say 1 2 3 and then I say head X, like X is still 1 2 3. I've not changed X, you know. So yeah, that's kind of, there's this forced constraint of like purity and immutability. Like there's no mutability and there's no impure function. So like you cannot call a function, you cannot call an IO function from like a normal mathematical function. Like you can't say like our add function that like adds two numbers. We can't say like first log its inputs and then like add the numbers and return the result, because you would have to have in the type signature somewhere like you would have to have like an IO int somewhere, basically to tell the runtime like, hey, we need to do some IO here. So it's like kind of this forced purity. But yeah, why don't we hop into some problems, and maybe we'll run into more IO stuff that we'll have to, it will give us more of a focus and like a you know, instead of just kind of like rambling, we'll have like a point. So do you want me to share, or do you want to like, I mean, are you familiar with like CodeWars or?
Not that specifically. Like I can go to any URL you point me at, and we can. You're talking about a web. Would I have to make a sign in or something, like a profile?
Probably, but I think it's just like a off GitHub thing where you just say like.
Okay, what'd you say?
CodeWars. And I think the reason I like the Haskell challenges on CodeWars is like it lets you kind of defer the whole IO thing. Sign up.
Oops.
Sign up with GitHub.
Well, okay. Then link me.
Oh, it's saying maybe you have to prove our skills. Choose your language to begin.
Oh.
So let's do Haskell.
I just totally ignored this.
Yeah, I did too, actually. This code does not execute properly. Try to figure out why. So, int. So, yeah. So let's just do that exactly. How did you know to do that?
I don't know.
Yeah,
Okay.
that should work. Great job. Okay, now you can link.
Okay. List. Okay. Oh goodness. Sure. No. And Haskell. Wait, did I just uncheck that?
I'm not sure, actually. It's not very clear.
Okay, yeah. That's all I care about for now.
So then, yeah, so this is, you can do like multiple languages, but instead of rank up, let's do I think this is the difficulty. So instead of rank up, choose like fundamentals, I think it's called. Like this drop down.
Oh, here, I see.
Yeah, fundamentals.
And click training.
Yeah, let's do it.
Cool. Should I read this?
It'll be on the next page too.
Okay.
So okay, you can close that if you want.
So your goal in this kata is to implement a difference function. Here, let me see if I can make this bigger. See if that helps.
Yeah, that's nice. That's helpful.
Cool. Difference function, which subtracts one list from another and returns the result. You should remove all the values from list A, which are present in list B. Okay. If a value is present in B, all of its occurrences must be removed from the other.
Ah.
So.
Okay, so it's like there's some list of values on the right and you need to remove them from the list on the left. Am I understanding that right?
Yes.
So then,
yeah, it's like set difference.
Yeah. So
if I run the, oops, I may have just done the wrong thing.
Oh yeah, no, so just run the test.
Okay,
yeah.
Cool.
Yeah, cool. So, so what I think we should do just to like demonstrate like maybe what would be a nice workflow like in an editor, why don't we copy this difference function and throw it in your lib file that we had.
Right.
And then you can just put it below some function. And then instead of undefined, type well actually, yeah, save this and then let's hop back to your terminal and see if you type :reload or just :r for short, we can reload and it compiled lib. And now let's do like :t difference and see if, and you might have tab completion. Was it called difference?
Do I need to like export it or something?
Oh, you're right. You do. So yeah, after some
func, do that?
Just comma difference. I think the cool thing to do is like all the Haskell like auto formatters do like the comma at the beginning of the line or whatever. Okay, so let's do a :r. See if difference. Perfect. Okay, so let's hop back to your editor and instead of undefined there, put put underscore to do. So that's called a typed hole. So let's save that and then reload your terminal again. Okay, so if you can bump the font down one or
sure,
because it's like wrapping, but yeah, there we go. That's helpful. So if we scroll the top of where this started, I know this is really noisy, but you get used to it. So it says found hole to do, and we have this double colon, which we're used to as reading has the type of. So what we've done is just ask the compiler, like, what is the type that this thing should be? I need something on the right side of this equal sign. What should it be? And it's telling you it should be a list of A. And then usually I kind of like skip all of this. I mean, sometimes it can be helpful. But then there's these relevant bindings. So that tells you a few things that are in scope. So we have a B that's a list of A and an A that's a list of A's. And then here's this difference function, but that would be like recursive because we're trying to implement difference.
Yeah.
But as we like solve problems, it can be really helpful to use typed holes because the compiler is so strict about types. Sometimes it's better to just like do the next thing and then like put a hole and say, what do I do now? And it's almost like type test driven development.
It's like TDD.
Yeah, it's like TDD, but even smaller increments of feedback. It's really nice. Once you get used to it, it's like kind of addicting and you like want it everywhere.
Right.
So let's go back, and I don't think this function in particular maybe is that great for typed holes, but I just wanted to show you that that's a thing.
Yeah, it's cool.
So, and also I just want to do a quick like time check. I don't want to like keep you on all night. So, do you want to just like do one or two of these and then call it a night?
Yeah, let's see. Yeah, let's do one or two. Let's do two.
Okay.
Let's shoot for two.
Okay, shoot for two. My PC might have just froze. Anyone out there on Twitch? Should we lose everyone? Do a shout out on chat. Okay, so you already were taking a stab at it, or these are the tests. I see.
Yes, so I stuck the tests in Vim.
Oh, nice.
Just wanted to get into the editor workflow. And yeah, ran them here.
Okay.
So got the same output that I got in the repl.
Gotcha. Yeah. So so what we need to do, right, is any element in the second list we need to filter out of the first, right? So let's go into a repl and look at the filter function. I think that'll be the best way to tackle that. So tackle. Oh, Todd also pointed out that the Haskell language server has some really nifty integrations with typed holes. So it's possible. I've never done it on Vim, but I think with VS Code and what I'm sure you could get it working, where you just like highlight a term or a hole or something, and it would like actually just tell you what it should be. So
I'll have to look into that.
So
that seems like it would be a really neat workflow.
Yeah. So I think the easiest function that we could talk about that returns a Boolean is just the double equals, which does probably what you would expect. So yeah, 1 = 2 is false, right? So why don't we just call filter like in here on your instincts are perfect. Like whenever you're like interested in a function, it's a great idea just to do :t and like just look at it,
poke at it. Yeah.
And also / Nathaniel just pointed out, for the people who are still on, thanks for sticking with all the technical difficulties. I really appreciate it. Sorry about all that. So awesome. Yeah, / equals is like not equals, I think. So
okay.
So you could do a T,
did this,
it should have the same type. Yeah.
Yeah. Same.
So
cool.
Yeah. So let's do yeah, that's true. So let's do filter, and then like let's pass actually just do do parens and then say either equals or not equals some integer.
Yeah. So
I would put the not put that on the,
Or on the
I
other
wonder if you
side.
could put it on the right. Let's put it on the right and see if it, or yeah, whatever. You could try
Like
putting it on the
this?
right. Yeah, I'm actually not sure if that's valid syntax. It probably,
We will,
yeah, we'll find out. So
we will
then just,
experiment.
yeah, let's not make it an yeah, that's good enough for now. Yeah, so that's
Scared you there for a second.
so filter, it's gonna look at each element, see if it's not equal to 1, and for any element that for which the predicate returns true, it includes it. So it's true that 2 is not equal to 1, so that gets included, right? So so we basically need to filter. So let's use typed holes. So let's go back to your editor, and then we know we're going to want to filter the first list, right?
Right.
So that would be A. So yeah. So
the first thing is a function. Like, I don't know. Maybe that's where you would put the typed hole because you don't know what it is.
right, correct. So
and then the second argument is, you were saying A, right?
Yeah. So this A here is going to be this value. So one thing like you see a lot in Haskell like convention is like you might call this, instead of A, you could make this X's and this could y, Y's, like just XS, and this could be like YS. Just to show that it's a list, but that A and B is fine as well. So if we just do underscore to do here. Hey Swarm, thanks for coming back to stream. My day's going great, minus the horrible technical difficulties we just had. It's fine. You guys are great, and Caleb's been a champ. I really appreciate Caleb being on the stream with me. This is really fun. Last time I had Pete on the stream, someone I met from doing this, and that was a ton of fun as well. Okay, so what does our type tool say? It says to do should be a function from A to bool, and then
right. Okay.
And then we might have some like relevant bindings if you scroll down a little bit, but I think we know what they are. They're probably A and B. So
yeah.
So if you scroll back to the top of that, to do should be a function from A to B. Well,
right.
we could probably sit here and work it out, but let's just continue with the typed hole approach. So wrap to do with parens.
Oops.
And then let's make a little lambda here. So do like a backslash X, and then a little stabby arrow. So now we're just saying, okay, you've told me to do should be a function from some value to a bool. So then,
Oops, sorry, I killed
no,
you.
that's fine. So now we've kind of like pushed the hole further down, right?
Right.
And Todd is saying, if you're running HLS, there's a code action for doing this. That's cool. I'll have to look into that. But so now we're saying, like, it said from A to bool, and we said, okay, suppose we took some A. Now what do you want? Well, to do should be a bool. So let's actually inspect the type of X. So relevant bindings. There should be an X. So that's one of the cool things about this is we've made this function, and we've basically, this is like saying, supposing we had an X, what would we need to do with it? You know? And then because to do is inside this expression, we can peek at what the type of X is. So X is an A. Presumably it's an element of this. The naming is getting confusing because there's an A. Actually, why don't we change this to X's and B to Y's, just to clarify a little bit. No, you'll have to leave the signature.
It doesn't matter there.
Yeah, the signature, it actually doesn't matter.
It's X.
Actually, change it to XS, because then that would differentiate it from this one.
XS, okay. XS. And
B to Y's.
B. Only one occurrence. We're lucky. Okay.
And then we'll need to change this to just X.
Right. Okay. That's, yeah. So we're differentiating there.
Yeah.
Got it.
So let's do another reload.
Okay.
And then we should still see to do should be a bool. Yeah, to do should be a bool. And then relevant binding should say, okay, yeah, X's is a list of A's, Y's is a list of A's, and X is a single A, right?
Right.
So what do we need to do? Well, we have this first one, and we need to check if any of the elements in the second list, basically if this X is any of the elements in the second list, right?
Right. In Y's.
Right.
Right. Like in plain English.
So, one thing we could maybe talk about now is, like, I mean, personally, I would start looking for like include or includes. I would probably just turn to Google. To be honest, I actually don't know what the correct function is, but we could also like talk about Hoogle. So if you pop open a browser and I actually don't know what the full URL is, but if you Google the word Hoogle, like Google with an H, yeah, then yeah, there you go. So this is like a search engine for types or for like Haskell functions. So I mean, we could just try typing include in here. That might be helpful. That's a lot of probably complex stuff we don't need. But what I was more thinking of is like maybe we need a function that takes an A. So like here, can I type?
Yeah, go ahead.
Let me see if I can find my cursor button. There it is. Okay, so I think what we want to say is like A and then a list of A's, and then our result we want a bool, right?
Yeah.
Is that?
Yes. Or the other way around, I guess.
Or the other way around. But yeah. So this first thing that comes up is elem. So it takes an A and a list of A's and returns a bool. Elem is the list membership predicate, usually written in infix form. Okay, so why don't we just try that in your like REPL and see if elem works.
Sounds good.
So we could just say
oops. Elem 1, 2, 3.
True. Okay, there we go.
Not. Well, add an extra E. And this is the function we want, right?
Is it?
Maybe. I don't know.
Yeah, I think you're right. Not elem.
Got pretty close there. Okay.
Okay, let's see if that compiles. I think you're picking this up really fast. I could see you falling in love with Haskell, I think.
Yeah.
Especially you're a big TDD guy, right?
Right, yeah.
Oh, import lib is a problem? Is maybe not elem isn't in scope or something?
Oh. Well, what was the
GHC list?
It says base.
Yeah, I mean it worked in your REPL, so it was in scope. Huh. Let's go back. Let's try and
Well,
just
like not elem. Not elem does not say base.
Oh, you're right.
So how do we not something?
Well, there's this not elem.
Oh, you're right.
That looks like, and not elem worked in your repl, right? So
Yeah.
can we just like kick the tires again, do another restart? Is that irrational?
Sure. Nope. Let's give it a shot. Let's see. Maybe I forgot to save or something.
Import lib. Is that happening in this file, or is it in like a test file? Or?
I think it's in the test file.
Kaleb test.
.hs.
So maybe the test file is not like valid syntax.
Yeah, this is the error.
Lib difference. Actually, I'm not sure. Maybe because, I don't know, it's like unused or something. Maybe it's just really strict. Yeah, try, did it compile before? Or have we gotten this to compile before?
Yeah, this has been running the tests. The tests.
Oh, it actually ran the test successfully?
Yeah, let me undo. Oh, no, I'm wrong because I don't know. Let me save this and see what test output is. Failure. It might be failing on the compiler. So when we got it to be a valid test, a valid code is when this error started appearing.
Okay.
So one thing we can do to just circumvent any weird issues with my setup is copy and paste this back into code.
Yeah, let's try that.
Okay.
That would be a solid try.
So window. Right. So we take that and run the tests.
Except we still have the typed whole version.
No. Yeah. What am I doing? This is what we want. Here we go.
Does anyone in chat know why we were getting that compiler error? Curious. Yo, there we go.
Did it.
So before we submit this, let me just point something out that's really interesting. So like, just like in algebra, you can have an expression like this, x plus y equals z plus y. Well, you can you could simplify, right? So, well, why don't we subtract y from both sides, and then we get y equals z, right? So, because there's kind of this substitutional equality with Haskell, like Haskell functions, we have this. I hope I'm not like gonna embarrass myself here. I think we can do this, is what I'm saying. Not elem wise. So this whole expression is a function that takes an x and then calls not elem on x and y's. But if copy just this part and let's look at run this expression in your well, I think it might have to be wrapped in parens like this. Run that expression in your terminal.
Okay. Let's see.
Are we still in the
variable not in scope?
Oh, just put a list instead of
put anything. Right.
Okay. Put the backticks back.
Put it back in the backticks. Got it.
Yeah. Okay, so this expression returns a function from A to bool, which is the same signature as if we did this, right?
Yeah.
It's the same thing. Because this expression, because it's infix, it's kind of like saying +1, right? That expression knows it needs another variable, like an argument to go on the left. So this expression is identical to this one. And maybe my x plus y equals y plus y thing, or y plus z plus y wasn't a great example, but yeah, you can just kind of remove this lambda and just use the backtick. You have to have the backticks though. But yeah, Chad is saying you could do flip, not elem, and then you would have a close parens, I believe.
Did that?
Yeah. So whoa. Yeah. So gain just popped up.
Flip.
First, I think let's just try the backticks versions and see if the tests pass.
Yeah.
And I mean, we're just kind of playing like Haskell golf, I guess.
Yeah.
Like Ruby golf.
Right.
But it's still fun to like kind of get it down to its essence. So yeah, let's try running the tests on that.
I can see how Haskell golf could be an addicting game.
Yeah, yeah, it definitely can.
It's really satisfying to get it down to just like, oh yeah, this one little short expression.
Well, and I think we can even go a little bit further. So, because let's see. Tot says, "Oh, it gets absurd." Let's see. Nathaniel says we're using backticks because we want to partially apply on the second argument of not elem, not the first. Okay, yeah. So we need these because the second argument kind of to like not elem. Yeah. So I think that's why he was saying you could say flip not elem. Wise. But I think so. If we take this, copy that line and then go to a site called pointfree.io, and then we'll be done. I swear.
All right. Pointfree.
Yeah, pointfree.io. And this is kind of cheating, but yeah, if you paste it in that first line.
Oops, I've gotten it. Let's see. Okay.
And then convert. So.
Okay, I was thinking it was headed this direction, where the x's and y's would be implicit.
Right. Yeah. So now difference takes no arguments, right?
Yes.
Because this is like this on the left will evaluate to some list, right? This will evaluate to some list, where it's like you can say this function applied to these two arguments will be a list that's equal to this expression that evaluates the list, or you can say this function is equal to this function. Now at this point, I would not do this because that's just that I find that to not be readable. But sometimes this website can be helpful, Yeah. So yeah, I say we just go with what we have, and we'll submit it and call it a night. Masaidu says that's the point. That's funny. So yeah, so Pointfree. So I think
I was going to ask, what does that mean?
The etymology, it's kind of funny because, like let's say we did. Actually, there's a specific word for this. So if I say, like map +1 over x's, where I could just remove the x's on both sides, right? And just do difference equals map, 1 plus, I guess it flipped it. So this specific type of reduction is called eta reduction, like the Greek letter eta or eta. Ada reduction. But
Okay.
this variable is called a point. So I don't know why that's the terminology, but it's like it's the point at some point in the expression that's like a named variable. That's what a point is. So point free is when you remove all of the quote points from the expression. But what's funny about that is sometimes switching something to being point free often involves using like the composition operator, which is a period, which looks like a point. You know, so
right.
So like for instance, if we did like +1 combined with, you know, +2, and then let's say we did this on X. So let's just say foo X. Then it'll probably oh, it's smart enough to just do that. That's funny. That's funny. But I was thinking it was going to remove the X and change this to a point or a period. But when you see all like composition and like no variables in the expression, that's point free. So it's kind of like it's just like a convention or a style of writing code. Like you'll hear people talk about point free style. I think it's just kind of a subjective thing. It's like you go as far as you think it makes it more readable, and then at some point you stop. Otherwise, you get like tons of flips and tons of compose with compose, you know, and like composing things that compose things, and it's just like you actually lose your understanding. So I think if you go back to CodeWars, then we can submit our answer and get our final closure.
Cool.
So
awesome. Attempt is what does that.
I think it runs like a more robust test suite or something. Oh, and then submit.
Randomized testing. Interesting. Submit.
Submitting your final solution.
Very cool.
And we can see what other people submitted, which is kind of fun.
Yeah, leaderboard.
So I think this is our like exact implementation. Cool.
What is this? Is like
so this
the most
is
common one? Or?
Yeah, so this is saying 13 similar code variations are grouped with this one. So plus 133 more warriors did it this way. And then you can like upvote answers you like. So I think this is a helpful tool because you can see how other people implemented it, and a lot of times if you see a submission that has a lot of upvotes but you don't understand it, you can kind of pick it apart and figure out, you know.
Yeah.
Well, anyways, I think we should call it a night, man. I really appreciate you spending this time with me. I want to thank chat for hanging with us, and thank you for all the helpful tips and suggestions. That was really helpful, genuinely. And thanks for hanging with me through the stream crashing. I appreciate that. And thank you so much, Kaleb, for joining and learning some Haskell with us. I'm really excited. Your enthusiasm is exciting. It's always fun to have like people interested in Haskell. And I mean, I'm very much a beginner, so it's a good learning experience for me to like explain to other people. And and Gabe, Damien, thank you for following. And if anyone else, if you're interested in these kind of streams, usually I'm going to do a little bit of shameless plugging here, Caleb. Hope you don't mind. Welcome to the stream, Gabe and Miss Saidu. I appreciate the follows. And so what I've been doing is going through this Haskell course called the FP course, where you basically re-implement a ton of stuff like in the base package of Haskell. And Kaleb, if you're still interested in doing more, we could go through some of those like beginning modules of that. That would be fun. Or we could do more of this kind of stuff. But yeah, if you're interested in following along with me going through the Haskell like FP course, would appreciate a follow. And yeah, I stream every like Monday, Wednesday, and Saturday, starting at around 7:30, 8 o'clock Central Time. So, but yeah, I'm gonna call it a night, and thank you so much, everyone, for joining. Gabe, sorry you just got here. Maybe catch us next time. And yeah, that'll be it. Everyone have a good night, and we'll see you next time. Peace. Oh yeah, Kumi AU coming in with a follow right there, snuck it in at the end. Appreciate it.
Awesome.
Yep. See you next time. Oh, my dog. It's like